Hi, good morning. Today's class, what are we going to see about? It's about forces. Now, I will in this session we will only see about how resultant forces are acting on a couple of situations, because those are the common ones that comes in Excel or CIE, where you need to be able to in a position to analyze what are the actual forces acting on the particular object at that point in time, and how to combine them all correctly, and then proceed to calculate any missing forces or angle and so on. Okay, that'll be today's session. Let's quickly jump into action. Yeah, the first situation that we are going to look into is inclined planes. I would, based on my experience that I have come across in situations where in past papers there are three main situations. One would be suspended objects, another one would be inclined planes, the third most common would be the lift accelerating and so on. All right, so we'll see that in three different sections. But before this, you should be familiar with constructing free body force diagrams for all objects. Now I'll just give you a quick introduction of what is free body force diagram if you haven't watched or if you are not familiar with. It is about constructing all those forces acting on an object in a particular point in time, but then if it is in contact with other surfaces, we ignore them. We just isolate the object and then draw all possible forces that are acting at that point in time, and that is free body force diagram. So what's the significance of a free body force diagram? That will kind of help you to identify the state of the object. What could the states of objects be if the object is moving, or if it is at rest? If it is at rest, of course, all the forces should be balanced. Now, if it is moving, it could be moving at constant speed or accelerating or decelerating. Now, we see here I've written equilibrium. Now, this is a term that you need to pay attention to if you're analyzing a situation. Equilibrium means all the forces acting on it are balanced. Please don't use the word equal. That will be wrong, because even if the forces are equal, it could still be accelerating or decelerating. I've explained that in another session in Newton's laws. But here equilibrium means all forces are balanced, and the object, if it is already moving, then it's going to be moving at constant speed, or it would be at rest. Now unbalanced, obviously there is a resultant force acting on it, and the resultant force will be the reason for it to accelerate or decelerate. All right. Now here I've considered this object to be in equilibrium, but I'm not interested whether it's moving at constant speed or at rest. Either case, the analysis of the situation will be the same. Okay. Now unbalanced, obviously, as I said, there will be a resultant force. Why I put both together here is certain steps are the same, and then how do we differentiate in terms of calculations? We'll see that as well. Now, any situation such as this, or as I said, suspended objects or so on, first thing is to identify the forces. That's a free body force diagram. Identify the forces acting on that particular object. So what are the forces acting on this object? Now here, usually we take the free body force diagram from the center of mass, but for convenience and for easy understanding, I would take the point from here, right? Now you have the weight that is acting vertically downwards, and you have the contact force that is acting perpendicular to the surface, right? And from here you will have the frictional force that is opposing it. All right. Now here I said it is in equilibrium, so definitely there is a component of force here, but for free body force diagram you will not represent the component of forces. Now here, how do I connect, or how do I bring this angle to this situation or to the forces? That's your first task. I repeat, the angle here is given to the horizontal, this theta. Now your first task of yours would be just bring that and figure out where exactly is this angle theta between, like which force or between which component is theta acting. Now how do we figure that out? You have to use your math skill. Now here this is a triangle, correct? To be completed, I get a triangle. Now it is a right angle triangle. This is 90 degrees. Now what would this angle be? This is going to be 90 minus theta, right? This angle will be 90 minus theta because you have got here a triangle. Now if I extend this, we all know the contact force will be perpendicular to the surface, right? Contact force is perpendicular to the surface. I have extended that line, so this line and the surface also should make 90 degrees, right? These two angles should combine to make 90 degrees. So obviously, if this is 90 minus theta, then this angle should be theta, correct? So this is like, you can save time while you're practicing questions or even in your actual assessments or tests. If you have the angle given to the horizontal, if the inclined plane is at an angle of theta, then the angle that it makes to the vertical, I repeat, the angle between the weight and the vertical line will be theta. So you can save some time, you can skip this working and connect these two angles. I'm not going to erase this. That is just for your understanding. So the same case immediately here also, you can just note down. So if you have weight acting W here, now angle to this will be theta, right? I've connected them both together. So once I get the angle theta, then I can connect weight's components with frictional force and contact force. How do I do that? Now these two are the perpendicular components of W, right? Now W is your resultant force here. It's acting at an angle theta to, if you take this as horizontal, that's your one of the perpendicular component. The other perpendicular component will be here, right? Now the component to be remembered, now this is like your adjacent side you can connect to the cos component, so that way you can easily connect it and remember. So this will be W cos theta and this component will be W sin theta. Notice the red lines are the actual forces and the green lines are the components I have drawn. Now if the object has to be in equilibrium, then these two forces must be equal, right? At any axis, if you take the forces acting on either side should be equal. Now since these two are acting opposite each other, contact force will be equal to W cos theta, frictional force will be equal to W sin theta. So W sin theta equals frictional force and W cos theta equals contact force. Now if you identify these two equations correctly, then solving the problem, the rest is like you have to apply your math skill. So what did we do here? First you have to identify the forces acting on the object like free body force diagram, then bring this angle connected to the point of contact, and then from there you just break all those components into its perpendicular, all those forces into perpendicular components, combine them, so you will arrive at two equations. Those two equations will help you to identify either the missing, usually they ask like weight, if you want to find out you can find that, or frictional force or contact force and so on. Alright, now here I've written unbalanced force. So both situations I'm just analyzing parallelly so for you to understand the differences. Here we equated them, but here will the forces be the same? No, forces will not be equal on either side. So how do we frame the equation? For example, if the object is accelerating in this direction, okay, it's coming down the slope and it is accelerating. So what does that indicate? Your forward force, so the force acting here will be greater than your drag, correct? Your forward force will be greater than your drag, or this force is greater than this force. Will there be any change in this equation? W cos theta will still be contact force because there is no movement vertically, or rather in this direction. The object is not moving, the object is moving in this direction. So we are only looking at these two equations, these two components, and these two are still balanced. So you will have this equation as this. This equation will change. How will that change? Since we said the forward force, that is the force acting here, W sin theta, will be greater or should be greater than the frictional force. So W sine theta greater than frictional force. I've identified that. Then how do I put it into an equation? Now here W sine theta minus frictional force. So this resultant will be equal, this difference will be equal to the resultant force. Correct? So this is greater. So this component minus opposing force will be equal to the resultant force, which will be equal to mass into acceleration of the object. Mass of this object multiplied by acceleration. So here the equation is slightly different, but here you get these two equations. As I said, there is no vertical movement. This W cos theta will still be contact force, but you can connect acceleration of the object and the sine component and frictional force. So once you get these equations correct, then after this it's only substitution. So substitution, and as I said, you have to use your math skills. Alright, so this is one such situation, which is inclined plane, where you have to remember whether it's in equilibrium. That's the first point, whether it's in equilibrium or not. If it is equilibrium, proceed with this type of calculation. If it is not in equilibrium, you have to proceed with this. I hope it's clear now. You can try like MCQ questions from CIE, where you'll find a couple of questions related to this concept, and you will get an in-depth understanding of the concept. See you in another video.